In this example, we see the analysis of variance for a one-way design, means comparing two or more means. Factorial design, type 1 and type 3 area sum of squares. Now open the data set. Here is the data. We have two columns, method and result. In the method, we have four numbers 1, 2, 3 and 4, 5. We have 5 methods that are the teaching method, and the next column is result. So the teaching method 1 give this result, and teaching method 2 give this result, and so on, so on. So now we see, now we compare means of all results of any teaching method. Now first go to the describe, summary table, describe, summary table, task, describe, summary table. Now here is the in the name, method is the classification variable, and the analysis variable is the result. This is the important part, summary table. Now first we make the summary table like here, drag and drop. Drag first, drag method. So first we drag method and drop here. Now we drag the result in this area. So first we drag and drop our variables. Now we here is the bottom, we see the available statistics. First we drag and drop mean. So click here, go to the here mean, and we just drop here mean. Now again we select another statistics, standard deviation, go here and drop at the center of this section. Now here if we see, there are different views. You can see there is a different area. We can drop here, we can drop here, we can drop here. Now we drop in the center. Now we take the n number of rows total and drop to this area. all method. Now here we select this bottom. We can select anywhere like this one, this area or this area. For total we drop it here. Now run this query. Click here to run. Now we get our result. There are five methods, teaching method, and each have a mean, different mean, uh, and standard deviations, and all are 9 observations. So here we see that the mean, average mean is method 3 is having a higher mean as compared to the other one, but the standard deviation is 2.46 is the minimum for that one. Now we see the another method is it's called the box plot. Select here our data, go to the graph, box plot, box plot, data, method to the horizontal, and result to the vertical. Now run this. Now we get the box plot, and we see uh, here there are two outliers. That's why it gives the higher value. Method 3 result 24 and method 3 result 23. So due to this reason, this method is going to the high mean. Now now we compare to the, now we find the, now we make the ANOVA. Click here, go to the task, ANOVA, one way ANOVA. Same as result is dependent variable, method is independent variable. Run this. Yellow icon shows that it's running. This gives the F test. This gives the result of F test. Now we get our result. Here we see that the value of F value is higher, and the probability is very small. So because this is the F test, so it makes some assumption. What is the assumption? There are three assumptions. Uh, the observation in each level of the factor variable arise from a population with a normal distribution. The second one is the population variance of the difference level of the factor are the same. And the third is the observation are independent of one another. So we just see one more test. It's called a Chevy test. So modify the one-way ANOVA. Mean comparison. Chevy's multiple comparison procedure. Other are the same things. So this method gives the result. Chevy makes a grouping, means which uh, which 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 method is the same. So it makes some group like A, B or C. So in this method we get the value of method 1, value of method 3 and 4 are the similar, and same as the method 4, 1 and 2 are the similar, and the method 1, 2 and 5 are similar. That's make a 3 groups. So now we run this one and get the result. We change the task. Now another example for analysis of variance. Open data. Wait. The data is according to weight of rates. So here is the source. Basically the rates give the two types of cereal, beef, two types of food. One first is beef and second is cereal, and all are the two types. So low and high regarding protein, and they watch the weight. So now we see the here we see the box plot. right as the horizontal, weight gain is the vertical. So basically the four columns is here: diet, source, beef and cereal, level, low or high, and weight gain. Now run this one. So these two are high beef or and low beef, and the high cereal and the low cereal. It shows that the high beef value is the more high beef is the more protein. Now we analyze one more thing. Now we create a summary table. Select the data source. Select source, as a classification variable. Also the level is the classification variable. Source, classification, and the weight gain is analysis variable. Now we create the table. Level for the low row position, and weight gain to the column position. Drag the mean, median, mean, to the left edge of n. So mean is here, standard deviation, now we run this one, summary table. Now here is the shows that the almost standard deviation are equal, but if we see the mean of high beef is very high. Now we create a linear model, analyze task, ANOVA linear model, task ANOVA linear models. Select weight gain as a dependent variable and uh, source and level is a classification variable. Go to the model tab, select both with control, mean, cross, factorial. Go to the model options, and confidence limit for parameter estimate. Now we get the p-value, f-value of all source, f distribution value. Right here is the ANOVA. This example is related to linear regression. Now import the data, select the data ice cream, file contain field name on record number 1. So record number 1 is the name, and rest of the data with delimiter field is comma. Just check next, finish. Now we get the 4 column. One is the ID is the observation numbers, and one second is the consumption, third is price, and 4 is the temperature. So we will see the what is the effect of pricing and temperature on a consumption. So consumption is the dependent variable, and price and temperature are uh, exploratory or independent variable. Now first we going to uh, plot a scattered plot of these two variables. Graph scatter plot. Price is on horizontal and consumption is on vertical. Just to dot. It seems no relation between price and consumption. Now we take consumption and temperature. Temperature on a horizontal axis and consumption and on vertical axis. We change only the horizontal axis. Last time we get the price is on a horizontal axis. Now we say, now we'll check. Now we check the behavior of this one. Sun dot, and it seems some relation between temperature and consumption. So we will see. We will plot the linear regression and analyze the relation of that one. So it seems some relation is positive relation between temperature and consumption. Now select the data. regression, linear regression. As we discussed, the conception is an independent variable and price and temperature are exploratory variable. We select both of that one. So select all. In this analysis, we get the histogram plot of the residual by predict values plot, standard residual by predicted plot, and also all we get the analysis of that one. So we just going to run this one. Running proc regression. Now we get the result. Number of observations are 30 observations, and first is the value of f. F test value is 23.27. The value is very high, and also the p value. The p value is very low. So we just reject our HO. Now here is the R residual square. R square residual square is 0.636328. Is very high. Again here is the next conclusion is the if we see the price is minus the price in minus 1.40 means if the parameter means consumption the consumption of 1 degree is the price is going down. Consumption is increased, the price is down. Otherwise, we can say that consumption decrease with increasing price. And here is the temperature. Now here is the positive means that if the temperature is increased is 1 degree, then the consumption is 0.00303 is increase, because we select all of the uh, plots. So here is the distribution of residual for consumption. Residual by predicted for consumption. These are the residual plot. Consumption versus observed by predicted for consumption. Q test residual fitness test, residual for consumption, fit diagnostic for consumptions, all are here. So these are all tests we get that one. Now we take another example for the linear model. Go to first the import the data. First one is cloud. Here is our data, and we see how rainfall is related to the other variables, in particular to determine the effectiveness of seeding. So because this is the weather weather department weather conditions data, now we're going to see some plots. So first is we make the box plot. uh, Graph box plot. Two-dimensional plot like the data. Select the rainfall to vertical and seeding to the horizontal. So this is rainfall versus seeding. Now we make another plot. Data. Equation is now take the horizontal and same rainfall to the vertical. So this is the box plot, rainfall versus equations. Now we make some, because we want to see the effect of rainfalls. So we make the scattered plot. Dimension data is the data is rainfall is the vertical, and time is the horizontal. Okay. You can draw and see all rainfall versus SNE. What is the behavior of that one? Same as rainfall versus cloud cover. Same as rainfall versus preview wetness. So this is a plot and you can see the behavior of the data. Now we going to analyze this one, analyze the data through model, just going program, the task, linear model, ANOVA, linear model. So we get rainfall is the dependent variable and others are quantitative variables. Under model, select all variable to the main window and we select seeding versus time, seeding versus SNE, seeding versus cloud. This is a seeding versus pre-witnesses, witness, seeding, promotions, and we're going to run this query. Yeah. So we get the result of our number total observation 24, F value is 3.10 and P value is 0.03, and here are the result of variables as well as all the residual. Now we're going to draw the line plot. We select the multiple line plot group by a group column, data, and the data we select rainfall to vertical, ascending to horizontal, and seeding to the group. See the appearance plot. Under one solid, select the dashed line. Symbols are triangle, and the height is 10 points, and the color is green. Dash line, triangle, ten points, and the color is yellow. Now go to the interpolation. Select the regression, and also here is regression. Not in the graph. We can now export this one. Proceeding yellow. Just change the color because yellow is not visible. Just change the color red. Replace this one. Now we get the clear of the both our lines and the points. Rainfall versus reading.